starting tomorrow, for today you're going to do salt problems, but tomorrow you are going to be given a set of problems. You're going to have kind of a work day in class where you're going to have a set of problems that are a mixture of everything. Weak acid problems, weak base problems, and salt problems, all mixed up. And it's not going to tell you what you're dealing with. All it's going to do is tell you the chemical formula. So just like last night's homework, the very first thing you have to do is look at your substance. So for this problem, we take a look at the NaClO here. We know this is a salt because it starts with a metal, okay? I told you yesterday, you don't have to show work for this thought process. So if you want to do this in your head, you can say Na came from NaOH, which is a strong base. ClO came from HClO, which is a weak acid. Therefore, this salt is basic. Okay, once you know that it's basic, that is telling you that you are going to want to use the anion. Okay, so that gives us that information. Now, before we can write our actual anion equation, the first thing we have to do is show that substance dissociated. So let's go ahead and do that. Remember, we're using a single-sided arrow for this because it does completely dissociate. This is not the basic part of the reaction. This is just what happens when you put an ionic soluble substance in water. It will break up. And we've already established that this right here is what we care about. This ClO minus ion is what we care about. Now here's the reason that you have to show this equation. If you look in the original problem, they told you that the salt solution's concentration was 0.030. But that's the concentration of NaClO. We are not using NaClO in our equation for our table. We are only using the anion. So all I care about is this one's concentration. Okay, we learned how to do this back in September or so. We've been dissociating and figuring out concentrations. The ratio here is 1:1. So if this concentration is 0.030, then this one is as well. You have to show that step on your paper. Okay, you have to. If you just use the 0.03, have the thought in your head, and then just use the 0.03, I have to mark you off. Because to me, on paper, it looks like you're using the whole salt concentration, and that's not what we want to do. This salt very easily could have been Ca parentheses ClO parentheses 2, and then the ratio would not have been 1:2, and then you would have been wrong. Okay, and that's very likely that they'll give us a salt like that. So you want to make sure that you're accounting for it. So that's step number one. Show the dissociation, figure out the concentration of the ion that you care about. By the way, is this one also 0.03? But do we care about Na? Couldn't care less. Okay, that's just going to float around in the solution and do nothing. So now we're going to go ahead and take our anion, which is ClO minus, and we are going to react it with H2O. So you're going to take whichever part was necessary. In this case, because it was basic, we're taking the anion. We react it with H2O. It's going to steal the H plus, making HClO, and then leaving behind OH minus. We knew it was basic. It made OH minus. That confirms that we probably have done this correct. Okay, just a little thoughts for you to have. Now that you have your equation, now it's just a regular old problem. You're going to put your table. Whoa. That was weird. Okay, so you're going to put your table around it. Make sure you cross off the H2O column. Don't want you to forget and try to use it. ClO's concentration, ClO minus's concentration is 0.03. Before this reaction even takes place, we have 0 and 0. You have X, X, X. They're all ones, but I'm going to make this side positive and this side negative. You have 0.03 minus X. We have X, and we have X. The problem has asked me to figure out what Kb is from the pH. Okay? I know some of you are probably working. I need you to take a break. Set your pencils down just for a second. I need you to listen to this part. It's really important. Some students try to cheat around figuring out this part the way that I've taught it to you. And what will happen is I will have students get it wrong, and I'll say, well, why did you pick it? And they'll say, well, I thought it was basic because it asked for KB. And if it's asking for KB, then it must be a basic solution. That is not true, okay? They can actually give you the KA for a basic solution. Do you have an equation that relates the KA to the KB? KA times KB always equals 1 times 10 to the negative 14th. So they will intentionally give you a KA for something that you want a KB for. And they're doing that so that you can't cheat around not knowing what kind of salt it is. Okay, so please keep that in mind. Now, for this one, it is basic, and they already are asking us for KB, so we're fine. But I need you to keep that in mind as we're working through different problems over the next couple of days. All right, so they gave us the pH. We need OH minus. So we're going to take, there's a couple ways to do this. I'm going to take pH plus POH equals 14. pH is 10.5. That should be a plus. Plus POH equals 14. That makes my POH 3.5. Then I'm going to take the POH I have. The negative log of OH minus, like so. I know it's 3.5. I'm going to take the inverse log of the negative of the pH. I'm going to get 3.162 times 10 to the negative 4th. If I remember that right. That's my OH minus concentration. So I can bring that back up to my table now. My OH minus goes here, 3.162 times 10 to the negative 4th. That also tells me this one, because that is what X is now. And then over here, so I have all my concentrations. The question didn't ask me for the concentrations, it asked me for KB. And since this is a base, that is what we are calculating. So KB will be the concentration of your products, both raised to the first power because their coefficients are 1, over the concentration of the reactant. The only reactant that matters is KClO minus. I'm just going to write this as 3.162 times 10 to the negative 4th, but squared. Since both of my products are X, they're both that same number. I'm going to run out of space if I don't. And then this will be 0.02968. KD comes out to be 3.4 times 10 to the negative 6. Is this calculation right here of KB new at all? We've been doing that, right? For a while, week or so. Is this right here new? pH and POH conversions? No, we've been doing that since last semester. Is this table setup new? No, we've been doing that for weeks because of last chapter. This equation, probably the newest part because we just learned that yesterday, okay, but that's still something that we've learned before. This dissociation may be new to these problems, but have you been dissociating and figuring out concentrations forever? Okay, forever being since September. Yeah? I mean, you know how to do all of this. It's just a matter of putting it all together. Understanding what you're doing will allow you to work your way through these problems. And they shouldn't be any more difficult than a KA or KB. They do involve more work. Okay, you do have a little bit more you have to do with them. But as long as you understand what you're doing, you shouldn't run into too much of an issue. Hi.